Okay, if I can have your attention, tonight we have one of our club members, Fred Erickson, KB0LF, and he's going to show us how to model some field day antennas. So, thank you, Fred.
Howdy. Well, next month is field day, and Jim Kilby and I are hoping to set up 2 CW stations this year at the field day site. Last year, Jim and I worked together. We had 1 transmitter. This year, hopefully, we'll have 2 of them going. And he and I enjoy talking about antennas and the planning for setting up the stations. And in the course of talking about the antennas that we might use, we had a number of questions. And I enjoy doing modeling of wire antennas using EasyNet. So I thought that I probably could answer some of the questions that Jim and I had about our antenna suggestions using EasyNet. In fact, to a large degree, I think that's true, and we're going to talk about that here. Our original idea for the 2 stations was to have 2 antennas. Jim is going to, let's see, that doesn't reflect off that. Interesting. Go behind and it isn't going to. Let's see. Go back here. Jim is going to be on 20 meters the whole time. That's the premier band in terms of making a lot of QSOs for the weekend. There's an antenna that I've used in the past for 20, and that was our suggestion, is what we have been talking about. It's a 2-element array using 2 verticals, and I'll talk about it a little bit. I'm going to operate on 40 and 15. Those 2 bands are complementary in one way, because a 40-meter dipole will load up nicely on 15. For a half-wave dipole on 40, there's 3 halves of a wave when you operate on 15, and the impedance, the driving point impedance on 15 is pretty close to what it would be if it were just a half-wave dipole. And in fact, last year, we had a single vertical for 20 meters, and we had just the 40-meter dipole. So these are the 3 antennas that principally the first 2 are the ones that Jim and I talked about last month or 2. And as a result of looking at some of the patterns, especially the pattern of the 40-meter antenna on 15 meters, and I'll show you that, a model of that, it suggested that it would be good to have a second antenna on 15 to cover some of the places where there are nodes in the pattern. Let's see, back here. As I started to do some modeling of the antennas and to look and try to decide whether the antenna was likely to be a good performer or not, I needed to know what stations we were trying to talk to. Where were they? So one of the questions was, what geographic distribution were they? Another question, which impacts the optimum launch angle for the radio wave from your antenna, another question is, how far away are the stations? And I was pretty sure that most stations are east and west. That's where the population centers are. Nothing magic about that. But I wasn't too sure what the distribution of distances would be. Adam sent me the log from last year's field day. And what I did was select out the 252 QSOs that we had last year on 20 meters. Just took those, and for each of those QSOs, I made, I put that into an Excel spreadsheet, made a column, and for each QSO, I made a guess about whether the station that we had just talked, that station on that line was a local, what I call the local QSO. So that would be states neighboring Nebraska, South Dakota, Colorado, Iowa, or whether the station was on the coasts, East Coast and West Coast. And if it wasn't either of those two, I called it regional, and so it'd be somewhere in between. For each of those stations, I also listed whether I thought it was to the north, northeast, east, southeast, and did an 8-category selection for each one. Then what I did is I sorted that, looked to see how many stations were east, west, how many were to the coasts, and data, first set of data are in this view graph. Up is north, east is to the right, west is to the left. The red line represents a connection of the points. And like you expect, east and west are where there's the most stations. But what is really surprising to me, that was 97. And most of the stations are around 20. So 97 is almost 100, 20, it's almost 5 to 1 weighting of the stations to the east. And for the western stations, it's more like 3 or 4 to 1. So whatever antenna we have, now this is 20 meters. The antenna that we had last year was a single vertical, so it was omnidirectional in azimuth. So there's no bias in this data that came from our antenna. So the antenna that you would put up to sort of optimize that pattern would be something that had a lobe to the east and the west, not worrying too much about north-south. Also, this is what the distances look like. This is again on 20 meters. This is last year's data. This is coastal, so that's all the Atlantic coast stations from Maine down to Florida, or Washington, Oregon, California. Local, very few. Regional, in between. And it's 2 to 1 in favor of the coasts. So whatever antenna I have on 20 meters, I really ought to have whatever launch angle gets me to the coasts, about 1,000 miles. One of the things that I have done before and did here, I went back to the antenna handbook. It has a great graph of distance versus launch angle for F layer propagation and E layer propagation. 20 meters and 15 meters during the day is likely to be F layer. So the wave's going to go up a couple hundred miles, 2 to 400 miles, and come back. And to get to the coast, from that graph, roughly the takeoff angle ought to be 10 to 20 degrees. For regional contact, it ought to be somewhere between 20 or 30 and 45 degrees would be the optimum angles. So we'll look at some antennas here a little bit, and we will, on 20 meters, we will look to get to the coasts, and we'll look east-west.
On 15 and 20 meters and even 40, is there any E-skip at all?
I think the E-skip is for 40 meters in the daytime. I think there's enough ionization there to be short.
Okay.
One of the things that I didn't do carefully is I didn't do the distance calculation of the 40-meter data from last year, which would help to confirm.
Well, I'm mostly interested in 15 and 10 and 20 because I just don't have the space to put up the bigger antennas.
I think you need a lot of ionization to get E-skip.
Right.
You would have E-skip if 6 meters was open. You can have sporadic E, little ionization patches.
Yeah.
When that happens, then there would be an E path, and that would certainly affect 10 meters and 15 meters also on that one path. So you have a local, and when that happens, it's sort of a localized area of ionization.
Right. Okay.
No, I'm thinking that 40
you.
meters in a day is E. That's my assumption here. So, what antenna would, I was suggesting to Jim that we use a 2-element phased array. It's not an elaborate phased array because it's not switched. It's corporate fed, so the single coax and the transmitter goes to a T. It's split on 2 wires, 2 coaxial cables, RG8X, I think is what I was using. And the lengths of those cables are the same, so you have the same voltage feed to each of the elements. They're a quarter wave in height. There's a ground plane for each one. There are 16 elements soldered to a wire, and the 2 elements are separated by half a wavelength. If they're half a wavelength apart, signal from one takes half a wave time to get to the second one, and the voltage in that one has changed so that 2 are out of phase, 180 degrees out of phase, edge on. So the pattern, the maximum for this pattern is the bisector line between the 2 vertical elements. And if you did a model, that's what you'd see. It's a figure 8. In this is an easy neck model of array. I don't think I can. I try to bring up. I can show you how easy neck looks later. I'm afraid of losing this and trying to get to. If I try to go back to the easy neck. In any event, so this is ideal because we looked at the distribution of stations from last year. It's all east-west. This antenna broadcasts mostly east-west. They're verticals, so they have an elevation pattern which is large towards the ground plane, even with a real ground. So I get a low angle of radiation, and I match the pattern of stations that I need to work. One nice thing about this is that when you're broadcasting with this antenna, you're broadcasting automatically at the same time both east and west. So an advantage to this, rather than having a beam where you might have to turn, is that you're going both ways all the time.
Yeah, I'm just wondering, if a vertical's 50 ohms and you got 2 of them split, does that make 25 ohms, or do you come up
It
with
does
50?
make 25 ohms, and I use a tuner.
Okay.
Yep, no, it sure does. You bet. Another nice thing is that because this is vertical and the 20-meter sideband station is often a horizontal antenna, there's a cross pole. One of the difficulties at field day is interference between a CW station and a sideband station on the same band. Your filters are bandpass generally, the ones that you get from DX Engineering, and they don't separate the CW from the sideband. So you need to be physically separated with your antennas, and because this is vertical and our sideband is likely to be horizontal, it's cross pole, so it reduces the interference. This is a really great antenna for the Midwest, 20 meters, because of the lobe that goes east-west. I hadn't appreciated the value, I mean, I sort of knew it, but I hadn't appreciated it quantitatively until I worked that. One of the questions that I had, I have used this antenna for field day, worked fine for previous field day, and I've used it for some portable operations, and it's worked well. But one of the things that I didn't know is the sensitivity to the distance between the 2 antennas. So if I set that out and I was off by a couple of feet, the actual distance is like about 34 feet. Does that make a difference? Answer is no. And when you look at the pattern, I don't have one here for you to look at, but this pattern with a slightly lengthened or shortened distance between the elements generates a little blip in between, and there might be a little bit of distortion in the pattern. Might be tip. To first order, hardly an effect. The other thing is the lengths of the antenna elements. There's 3 pieces of aluminum tubing that slide within one another. And the way I work that is to set it up about the right distance, and I have an antenna analyzer, so in the field when I set it up and get ready to go, I use the antenna analyzer and set the length for a particular frequency. Here it would be probably 14.050, so the middle of the CW band. And I do that for both of the elements. But if those are set a little bit differently, the question is, does that screw up the pattern? Well, a little bit, but it turns out not very much. And the simulations that I did, I raised one of the elements by 6 inches, came back to what I thought was about the optimum one, and then made it 6 inches shorter, so I did 3 runs. And again, the pattern gets a little bit distorted, but to first order, not much of a change. And so the antenna degrades gracefully compared against the changes in these parameters. So in that sense, it should be a good antenna. If you put it together helter-skelter, it isn't quite ideal. It's not a disaster. Last year, our 40-meter dipole was up about 20 feet, and it was a V. It worked okay. We made contacts. Question, let's see, I went out and looked at the field day site within the last week, took some pictures of the trees with a 7.5-foot pole at the bottom, and I could judge what kinds of heights we could reasonably get from either of the 2 locations where our CW stations might be. And we can reasonably get up 30 feet, maybe 35 feet, probably not 40. So a question is, if the antenna were up 30 feet, do we gain much from last year? Jim and I talked about that. We're pretty sure it's better. We didn't know how much. And I did some simulations with a V at 20 feet height, and also an antenna that was horizontal at 33 feet. And I get about 2 dBi increase, about 60% increase in the radiated signal on average. So where we might have been broadcasting with 100 watts, it would look like 160 this year if we raised it. We also talked about the shape. Does it make a difference whether it's a V, whether it's horizontal or a Y? The answer is relatively little difference. However, the V has a little bit more loss than the horizontal, has a little bit more loss than the Y. So the higher the ends of the antenna are away from the ground, the less loss. So ideally, you want horizontal or Y. That was kind of a surprise, because we talked about the Y, and I think when we both mentioned that, we said, yuck, why would you want a Y antenna? Well, actually, but it's relatively small. Bottom line is, for the 40-meter dipole, having it higher and about what we can get will make a significant difference. For those of you who might be interested in what the actual patterns look like after the talk, after I'm done, I can bring up the files and the models that I have and show you the EasyNet runs if you're interested to see how it looks. For the sake of expediency, I'm not set up to do that here. So what happens on 15? Well, originally last year what we did is we just ran the 40-meter dipole on 15. And when you do that, here's what the simulation looks like. This is at a low angle. This is just up 15 or 20 degrees, which would be getting to the coasts, F-layer getting to the coasts. And you can see there are lobes. It turns out that the gain in the lobes is great, actually. That's not indicated here. But you get a much bigger signal than you would from the 40-meter antenna on 40 meters. there are places where you won't have much signal. It turns out this would be to South Carolina, North Carolina. Up here would be to New England. You probably, depending on how you oriented that, I'm gonna figure that east-west is aimed at probably at Washington D.C. You would miss Southern California. You'd probably catch the top of California and Oregon. You'd probably miss Washington. So, and we did have some trouble on 15 meters last year. We thought, though, it was more the propagation, but it may also have been the antenna. So, how would you fill that in? Well, simple way to fill that in is with a vertical. Quarter wave vertical on a pole, elevated. I have some 3.5 foot fiberglass connecting pieces. You may have seen them at the down in Lincoln or any of the other places where they're selling antenna parts. Amfest. Couldn't get the word. And I have used those, there, 3 of them will go 10 feet, so we need 6 of them would go 20. So some of the questions then in regarding a vertical, is there a preferred height to it? I would probably have 3 or 4 radials, and my thought is to make this simple, the radials would probably be wire, and they would be just tied to guys at the top or at the base, and I have some 1/4-inch aluminum tubing, 12 feet of it, that will be the vertical piece handy. So that this antenna's not been made, hasn't been tested, but one of the things that I found when I modeled this at different heights, I found that the pattern really varied. When the pattern was low, or rather when the antenna was low, I had a single lobe that was about in here. That would go to the coasts, probably a good thing, but might not go, this is 45 degrees, might not go very well, might not work very well for a regional QSO. But I found about 20 or 25 feet that this is an elevation pattern now. So this is azimuthally symmetric. I found that you could find a place where those 2 lobes were pretty much the same. And so one of the thoughts is to have this antenna up about 20 or 25 feet. 3 or 4 radials, not much difference really. Optimum length for the radials would be a 1/4 of a wave. The 1/4 of the wave at 15 meters makes, since the end of it is open, it makes it look like a short circuit. And so that would give the driving impedance to be around 50 ohms or 75 ohms, which would be convenient. If the radials are other lengths, then you need a tuner, and you probably have losses in the coax. So, kind of bottom line, the phased array seems like a really good option. It's pretty insensitive to its parameters being, its physical dimensions not being ideal. Dipole, we need to get that up 33 feet or so, 30 feet, and we will have a significant increase from last year. And on 15 meters, my thought is to have the 40-meter dipole with its own tuner and the vertical with its own tuner, and have a switch so that I can switch back and forth in real time very fast, less than a second, get from one to the other, do CQ one way, do CQ another way, which I think would be, matches the pace of what field day contacts are like. So that kind of concludes it. You've seen some of the antennas that we are thinking about, and some of the thinking that went in behind them. I sure hope that you'll come, even if it will only be for 15 minutes or so, and out the field day site, come visit us and check to see whether we're making contacts to the east and west on 20 meters. When you do, you may find we're exhausted, so please be patient. This is our puppy dog, Teddy.
Bring treats.
Yeah, bring treats. He's a mixture of poodle and Yorkie. Thank you.
Was there any gain on the phased array?
Yes. It's like 4 dB, 3 or 4 dB over a dipole. And I did look at this because a question in my mind is a beam better? If I put up, let's see, I operated with K6AA in Los Angeles, a large club in LA, and on 20 meters they had a 4-element monobander on 20, and it was up 60 feet. So they had a lot of gain. This antenna would not have matched that. I went and looked up for tri-banders, Cushcraft, Mosley, high gain. Most of the gains for the tri-banders are about 7 to 8 to 9 dB. I called Mosley and asked them about how that's measured. Mosley and I think the other manufacturers specify the gain of their antenna relative to a dipole. So they make measurements by putting in a field up high, they put the beam up, go off 10 wavelengths, make a measurement of the field strength, put a dipole there and make the measurement, and then take the ratio of those two. So this antenna would be 3 or 4 dB over a dipole, and a good beam would be 8 dB. So that's almost an S unit and a half or 2 S units, so that's a lot. However, you need to make sure that the beam is up high enough so that you get a low enough lobe to make the coasts. If you put that, I took a single wire dipole and I tried different heights just to get a sense for where that lobe might be. If you were to take a tri-bander and put it up 25 feet or so, you won't get that low lobe. So you don't get the benefit of all of your 8 dB gain relative to the vertical.
Well, on the tri-bander though, as compared with the dipole, the dispersion of the elevation of the signal will be compressed on the tri-bander, so that your low angle loss, so to speak, will be diminished when that tri-bander is low.
I would challenge that, because I think your signal is going to hit the ground and reflect, and I think that's what's going to determine your signal strength at 10 degrees and 15 degrees. But I don't know what the beam width is in elevation for the tri-bander. We'd have to look at that and model it. But could be. Any other questions? Yo.
This phased verticals, is that bought or did you make it yourself?
I built it.
Okay.
I built it, and it was kind of fun. The first place I did a portable operation, and I took one of them. I had built one and set it up at a couple of different places, and it seemed to work fine. First place I used it was up in Stanton at Mascantine. I spent 3 or 4 days up there at the recreation area in the springtime, and it worked great. And then I used it at field day.
Stanton, Nebraska, or Staten, Iowa?
Nebraska.
Nebraska.
Just north of Stanton, Nebraska, yeah. There's a really nice park, Mascantine, M-A-S-K-I-N-T.
Never heard of it. I go up there sometimes. I've never heard of it though.
Well, it's just east of Norfolk, by about a 20-minute drive.
Okay, that's why I don't know where it's at.
Yeah,
Okay.
right into Stanton County and then south. And they have there's a creek that flowed through there, got dammed up, and it focuses on fishing. And they've, not at the dam end, but at the other end, they've got some peninsulas that they've built out. So if you want to fly fish or whatever, you can walk out on the peninsulas. And it's just a beautiful area. I was there in the spring. Everything was green and it was gorgeous. And it was before a lot of people had come to the recreation area. There weren't many people there. Everything was clean and been fixed up. So maybe I caught it at just the right time. It was beautiful. Yo.
Where do you set up field day? You didn't tell us that.
It's at a building that's looks like an old hospital, and it's somewhere in like 153rd and Maple.
That's where the Clearview ponies.
I didn't know if you were up in Fremont, because you didn't tell us, or
Sorry about
Staten,
that.
or...
Yeah.
Now I know it's with the club. I didn't know that.
Oh yeah, this is with the club.
Yeah, I didn't know that. Okay.
And one of the view graphs that I wanted to show, and I didn't get a good copy off of Google Maps, is the field day site. If you know that site, there's a real big green front yard, and one of the places for Jim and I, a possibility for Jim and I, is close to the building on the east side. In that corner, there's a bunch of trees there, or on the west side, which is where a lot of people set up last year. Pat, does it look like you guys are going to get a beam or not?
There's a good chance. Dave's working on the antenna trailer. There's a pretty good chance that it's going to be operational. So.
Outstanding. That's outstanding. That's great.
34 foot.
34 foot. I think you'll be okay. Yeah, that's dynamite.
Yeah, that'd be nice.
So do you think that you'll operate on where?
Well, we're discussing that amongst all of us, whether or not we want to have it set up by where we had the dipole
Yeah.
there, or off in the field, because the field will give us a little more space for the beam. But the problem, of course, is how far do we want to run the trailer over? I mean, that's a long stretch of grass.
And if
that we have to
we
roll it
get
on.
torrential rains like we had, you'll get stuck.
Yeah, it might drain better up by where we had the dipole and the 20-meter voice shaft last year. I would think that, more than likely that'd be the spot where we'll put the beam, but
Cool.
I think it's,
Well, I've looked, and Jim and I have gone, we've looked at both places
Right,
for us. So you guys pick what
Okay.
you like. We can, we've got trees and we've got an open area, and we can set up in either place. So-
okay.
Well, that'd be,
How much space do you need for the array?
it's just, it's 30 feet between
Okay,
and 16 feet off the end.
okay, well, that's not much.
60 foot, yeah, it's not too bad.
Okay,
And there's green grass open spots in both places.
sure, yep, yep.
Yeah, it's a fun little antenna. It's a fun little antenna. Thanks.
Thank you.